Hi, welcome everybody. Hope you're all well and enjoying your time at home. I'm going to try and do one of these for each of the lessons that we have, and we'll also have opportunities to do some talking to each other, and we can also, of course, type into the comments page in Google Classroom. Don't forget, all of this stuff will be on Google Classroom, so the PowerPoint is on Google Classroom. 1C, types of functions and implied domain. So an implied domain means it's something they assume. They're not going to tell you what the domain is. They're just going to assume that you know what the domain is, and it will hopefully become obvious to you which ones they are. A one-to-one function. So you might remember this from last year or even in Spesh. A one-to-one function is the horizontal line test. So if it can be drawn anywhere on the graph, it's a one-to-one function. Which of the followings are one-to-one functions? So let's have a look at this one. There's x squared, apply a horizontal line test. It touches at 2 points, this one here and this one here. So that one's not a one-to-one function. Sometimes you can visualize them in your head before you draw them. Probably for B, you can visualize that in your head and we don't need to draw it. Hopefully you'll know that that is a one-to-one function. So it only crosses the line at 1 point just here. This is a weird one. So this is the line y equals 5. So if we apply a horizontal line there, basically we've got the whole of the graph will be that dotted line. So this is not a one-to-one function. Y equals x cubed is a one-to-one, but as you probably notice, that's not all cubics will be one-to-one functions. Obviously, a semicircle or any sort of circle is not a one-to-one function. And here we have a 1 over x graph, and that is a one-to-one function. We draw it here, draw it anywhere on the graph. It only crosses at 1 point. So if you want to know if something is a function, we apply the vertical line test. There's a vertical line. I'm amazing. And if we want to know if a function is one-to-one, we apply the horizontal line test. So what's special about one-to-one functions? Well, we'll look at this in more detail later on, but if we have a graph there, looks to me like that might be something like x cubed. If we work out this graph here, which is the inverse of x cubed, and we put in the line y equals x, we can see that there's a reflection here. The graph, this side of the line and this side of the line are a reflection of each other. So in order for us to be able to do this, we need to have a one-to-one function. More on this later. So piecewise. So these are sort of so easy. I'm kind of, it's almost a waste of time going through them, but we need to because there are some classic mistakes which people have made. They come by different names sometimes. Back in the UK, we were always called them hybrid function. I'd never heard of the word piecewise function before. So it's just made up, this one here, as you can see, is made up of 3 different sections. So if it's less than 0, this bit here, it's this graph here, minus x minus 1. Between 0 and 1, it's this graph here, 2x minus 1, and if x is greater than 1, it's this graph here, half x plus a half. So they're quite annoying to draw because you have to draw 3 different graphs, so you have to do intersects and gradients and that for each of the graphs if you happen to do this without using a calculator. But we can see that once we've drawn the graph, we can clearly see that the range goes from minus 1, that is an absolute minimum, there's nothing below that, all the way up to infinity. So we can write that as minus 1 to infinity. Odd and even functions. So again, you guys might know this. Odd functions have this property, f of minus x equals minus f of x, but it also means that it has rotational symmetry around the origin. So I do apologize for this animation. It took me ages, but it's not particularly brilliant. So if we rotate this by 180 degrees, we can see that it ends up being the same graph. So if we go back again, we've got this graph, and if we rotate it 180 degrees, we get to that graph. So the 2 graphs are the same graph. So that's one rule. You can tell if something is an odd function. And the mathematical rule is the test that is if f of minus x equals minus f of x. If that is true, and you can test that algebraically, then the function is an odd function. So clearly, if there's an odd function, there must be an even function. Probably a little bit easier to work with even functions because visually it's a little bit easier. They're just symmetrical above the y-axis. So if we take out that one, we can see that we've got the same graph on either side of the y-axis. And algebraically, we can again prove it algebraically by proving that f of minus x is the same as f of x. So if we put it into a table, like a table, nice and easy notes. So odd function, f of minus x equals minus f of x. Even function, f of minus x equals f of x. For an odd function, 180-degree rotational symmetry with respect to the origin. Even function, reflectional symmetry about the y-axis. So put it in a table, much easier for you then to refer to it in your notes when you need to. And there's some work for you to get in onto. Probably should take you about 500 hours. Mr. Patch, over and out.